welcome to my session. My name is Oleg Zhurakousky. I work for Pivotal. This is my second time at Spring.io last year, and second time in Barcelona for that matter. Beautiful city. So quickly about myself. I'm originally from Ukraine. Moved to the United States around 90s. Lived there for a little bit, and then last year moved to France. So I'm kind of just across the border. My history with Spring organization is interesting. I joined Spring Source in 2008. Worked my way up to engineering on Spring integration. By the way, we're going to be talking a lot about it today, or touching on it. How many of you are familiar with Spring integration framework? All right, good. So I work as an engineer on Spring integration framework, and then around 2012, I decided to, you guys all remember the Hadoop, big data, that buzzword. So I decided to try myself in that area. Went to work for a company called Hortonworks, which is now Cloudera. And a few years ago, decided that's really not my cup of tea, and decided to come back to Spring team. Rejoined, and we have this interesting role, which is kind of important for you guys. We have a new role called Spring Advisory Architects, which are the actual engineers who are also visit the field. So they're committers on a variety of different frameworks, and so whatever business dealings you have with Pivotal and Spring organization, you may want to know about that we do have that. So it's not like your regular consultant, it's actual Spring engineer who also visits the clients. So I did that for about 6 months until the guy who was leading SprinkleStream decided to leave, and they were looking for somebody to take the leadership of the framework. So they offered me, I took it, and then later on the same happened with Function. So I currently lead 2 projects, SprinkleStream and Function. So, and that's what we're going to be talking about today. Also, just as far as the protocol, I prefer not to wait till the very end for questions. So I'll periodically stop. I'll say, if anybody has any questions, please do so, because I believe the question is more relevant when it's asked within context of what's just being presented, rather than wait till the end and so on. But if, for example, you kind of jumping ahead, I'm going to say, hold up, I'm going to talk about it, and so on. So let's begin. Here's our kind of a mini agenda. I only have a few slides. For those of you who know me, I spend most of my time just live coding. So that's what I'm going to do today. But I set the context with a few slides. So we're going to talk about cloud, event-driven architecture, kind of bring everything together. We're going to talk about primarily what's new, what's new in Spring Cloud Stream, and what's coming in a pipeline. So cloud, we live in an industry full of buzzwords, right? So today we have cloud. Rewind 10 years ago, we had SOA, and then we can rewind another 10 years and probably come up with some other buzzwords. But the reason why I'm kind of making sarcastic comment about this is because there is no definition of what SOA is. There's no definition of what cloud is. Everybody perceives it the way it is relevant to them. So when I talk about cloud, I at least want to set the context, what it means to me, right? So cloud is an ecosystem that integrates platforms and middleware into one cohesive hybrid runtime, right? So we're outsourcing infrastructure, we're outsourcing a variety of different connectivities and business processes to the cloud, because we as developers, we primarily want to concentrate on implementing functional requirements and don't want to bother with the sort of a boilerplate nature of today's IT environments. And for those of you who've been with Spring for a while, you know that's really our message. That's the historical message that we always had. We worry about the boilerplate code, leaving you only with the functional concerns. So Events. So this session is primarily about talking about event-driven architectures, and my goal is actually, as a lead of both projects, to primarily showcase the kind of a nitty-gritty technical aspects. What can you do with the framework? Not necessarily deviate into what are the practical implications of it. In fact, Jakob Pilemon, one of my colleagues who's going to be presenting right after this, he is a big advocate of event-driven architectures. He has a lot of practical demos and presentations and so on because he's a developer advocate. He visits the field. He does this cool stuff. So in other words, it's a kind of a nice transition to know what's internally going on, how things work together, and then see how it actually works in practice. So, so events. What is event? Events is a representation of state change. So when you receive event, what's in the event already happened. It's always in the past tense, right? So the events are delivered in a sort of form, protocol-specific messages, and be a variety of different middleware. So we can have, messaging systems, HTTP. I mean, you can argue that literally anything that can transmit piece of information is a messaging middleware, right? So not necessarily has to be like JMS or MQP or Kafka or anything else. So the interesting thing about event and why we kind of come up with a different name rather than just piece of data, because events, to me at least, means that there is going to be a piece of information and there's going to be a piece of meta information, right? So in other words, just like with the email, just like with a regular letter, you have a payload, right? That's the content. And then you have some additional information like properties, headers, address information, and so on and so forth. So, and in Spring, events are represented generally as messages. Message is, as you can see, it's a very simple structure. Basically, it's a tuple 2, so to speak, right? But it's really more structured where you have payload, which is literally an object, could be anything, and then you have a map of headers, which is basically the meta information that you want to transmit with your payload. And we're going to see it later on in action. So let's start writing some code. And again, I haven't really got into SprinkleStream yet, but I kind of want to show you a little bit and then start talking about some of the details. So before I even go, how many of you are using SprinkleStream or familiar with SprinkleStream? Okay, fair share, and also fair share of people who don't know, so which is good. So for those of you guys who are using it, what I'm going to show right now is probably going to be very boring because you've already seen it, or you've already used it actually. But for those of you who didn't, well, welcome. So what I did is basically, this is a blank sheet of paper. There is nothing. Disregard this person class. This is just a project that I'm going to use later, right, just to save time. And what you see is just a plain vanilla Spring Boot application that does absolutely nothing, right? So what we want to do is we want to be able to do something, right? And we want to be able to do something based on arrival of the message to, I'm kind of setting the use case, based on the arrival of the message to RabbitMQ, and for this case, right? Could be Kafka, could be anything. So we have binders, which I'll talk about later. But in this case, I'm going to be using RabbitMQ, okay? So I want to be able to send message to RabbitMQ, and I want to be able to somehow this message be transmitted to and result in invocation of my code. Now think about, in the good old days, what would you have to do that, right? Configure connection factory, session factory, all kinds of different things, message converters, and so on and so forth, right? So what I'm going to do is I'm just going to write simple method. Let's just make it more. So I'll explain in a second what I'm doing. So what I did, I've written a very simple, rudimentary SprinkleStream application, which was going to receive a piece of data, and it's going to, in this case, the piece of data is going to be a string, and it's going to uppercase it, right? So as you can see, at this point of time, there is absolutely no way for you to tell that this is going to be an application that's going to receive a message from RabbitMQ. That is what's going to come from the binders, which I'm going to talk about in a few minutes, right? So I'm going to start it. Oh. So that's not what I want to do. Come on, stop. So I'm going to start it, and it started successfully, and I'm going to go to my RabbitMQ console, and you can see there's a Barcelona group queue. Now, let me quickly tell you why. So basically, what I want to show you is that this is really all you need to do to make things work. But I did one additional thing, which is I defined that for my input, destination, and group, I defined the explicit names. Why I did that? It's just better for the demos, because if I didn't do that, it would create anonymous queue, which means every time I restart the application, it would change, right? So for development, you rarely have to do that. In fact, for development, you don't want to do it because you don't want to worry about cleaning up the queues and purging and so on and so forth. But for demos or for real life applications, you probably want to be able to have something like this, right? So, but that's, like I said, it's the bare minimum that you would have to do. So now we have application started, and I'm going to go to Barcelona queue, and I'm just going to say, hello, Barcelona, right? And send the message, and we received hello, Barcelona, and I can also actually go into, so the message came in, and the binders did all the work that I'm about to explain how everything works, right? And basically invoked my method, right? And then once I returned the output was, again, went to the binder who was part of my application and was sent to the output queue, which is eventually the output channel, which eventually went to the output exchange, which is bound to this output queue, which I did it manually. And I can go and say, okay, here we go. Here's my hello Barcelona uppercased, right? So you guys familiar with RabbitMQ? For those of you who don't, so the way RabbitMQ works is that when you're sending a message, you're sending it to the exchange. RabbitMQ is a messaging system that has internal routing. You send the message to the exchange. Within the exchange, it routes to a particular queue based on the instructions. In my case, the instructions send it to just that queue, right? So, and then so that's how the message ended up in my method. Then when the result went through the same process, it was sent to the exchange by the name, output, which, as you can see, bound to the out queue, and that's how we saw the message in the out queue. So that's really the full circle. Okay, so now a couple of interesting sort of features. So obviously, I didn't have to do anything. I just wrote an application, wrote a simple code, and simply by, let me just start showing you things. So again, we're living in the world of Spring Boot. So now we're kind of managing dependency and things via auto configuration. So dependency by POM, right, or by Gradle build. So it's the fact that I included SprinkleStream Rabbit binder into my POM. This is what made this thing work with RabbitMQ. Had I been using Kafka, all I would need to do, no change of code, no change of properties. All we need to do is just change this dependency from SprinkleStream binder Rabbit to SprinkleStream binder Kafka. And we have a bunch of different binders. And in fact, I'm kind of jumping ahead. We are right now formalizing the actual binding framework because we just realized there was an interest in the community to develop other binders for other messaging and non-messaging middlewares. So, so that's really the kind of the gist of it. Now, this is so far a kind of a simple application, but what if I wanted to do something more complex? What if I want to receive that guy person? Well, actually, before we go with that, I'm going to say, I want to receive a message, right? Because what happens when you receive the message from from RabbitMQ, internally within the binder, represented as a message. The fact that my method signature defined a string, that's the internal, that's the beauty of the framework. We, by convention, recognize that you really don't want the message, you want the payload of the message. So there's a convention going on there, saying that if you declare some kind of a poser, then we're going to assume it is the payload of that message. But if you want to receive if you want to receive the entire message, then you can declare, and because you, for example, you may be interested in metadata of some type, right? Then you can say value that, in this case, get payload dot to uppercase, but message. Okay, so now I'm going to restart it. And you can see in the console that we received the entire message. So now you can see the payload hello, but you can also see all kinds of relevant information, especially when it comes to where it came from, like the channels, the RabbitMQ properties, and so on and so forth, right? So now, again, if I wanted to say, listen, I don't want message, I want to receive a person, I want to be able to deal with the domain-specific objects, and I want you to worry about some type of conversion, I can do that too. So my person has a name attribute, right? So what I'm going to do, I'm going to restart it again, right? But now I have to represent it as a person. So obviously I'm going to send a JSON string, and it has to be, you know, something that so I received the person, right? So all of a sudden, it really, as you can see, what I'm sort of hoping that you are able to observe is that you only worry about the functional aspects of it. We'll take care of the rest of it. Now, when it comes to conversion, what you just observed, that happens based on the fact that we included about 7 message converters that we believe, and based on the feedback from the community, are most relevant. Yes, you can have a case where none of our message converters will be able to handle that. Okay? Guess what? There is, again, if you go through the documentation, and we actually revamped our documentation, we have a very kind of a nice sort of a look and feel and a lot of different information. But if you go to information, there is a stream message converter. You can define your own bean within your configuration, and it will be added as the first one. So you will get the first crack at converting something. So if basically for 90% of the cases, you can rely on message converters provided by us, but for other cases, you can simply extend the framework by providing your own message converter and so on. All right, back to the slides. There's only a few more, so. And then we're gonna get to the real cool stuff. So Spring integration I mentioned earlier. So to me, it's kind of a very sort of a nostalgic and very relevant topic to this day, because like, why do you, like, when I talk about Spring Cloud Stream applications, okay, so you develop an application. How does it really live in the real world? Well, you don't have a single application. You rarely have a single application. You have multiple applications that are connected via messaging middleware. So you have some process here, then there is some kind of messaging middleware in the middle, then another process, then another messaging middleware in the middle. So you're essentially building the flows, right? And that's really what Spring integration allows us to do. It's basically implementation of enterprise integration patterns. Everybody read that book or know that book? Or it's a very good book. I would definitely recommend it. It basically outlines a variety of different enterprise integration patterns and kind of puts things in perspective. So now when you look at the code or discuss something with your colleague, you really have almost like a different lingo. You say, well, this is a filter, or this is a transformer, or this is a router, or this is this. So there's various different patterns. So a message actually one of the patterns defined by enterprise integration patterns. So, but the very core pattern called pipes and filters, which is really what I just described. You have pipe, which is the messaging middleware, and you have a filter, which is basically a process that does something. and then sends it to another pipe, and process repeats, repeats, and repeats. And the beauty of it is everything is decoupled. Your producers and consumers don't really know about one another unless you want them to know about one another, and you do communicate the information through meta information in a message like headers. So yeah, the issue with Spring integration is that it's a framework that allows you to configure flows within a single application context, right? So in other words, you can do the same thing what I just described you, but it's within a single application context. The problem is we live right now in a distributed world, so we need a better way of doing literally the same, but in a distributed environment, right? So SprinkleStream effectively takes Spring integration to the whole new level, or takes the concept defined within enterprise integration patterns and Spring integration to the whole new level, right? So, and in fact, the binders and a lot of the internals of SprinkleStream actually using Spring integration as a library, right? Because there's a lot of code there that is reusable, not just as a first-class framework, but also as a utility library that you can use when you're building your own frameworks. And one last thing, just to underscore how much in love I am with Spring integration, I usually, when I'm in the field or when I'm trying to prototype a requirement which contains some kind of a flow, I start with Spring integration. I literally map it with Spring integration. Do you know why? Because I can actually run it. I can run the whole thing. I can implement my entire data flow, my entire enterprise data flow with just a single Spring integration application context. And that's what I did a couple of times with the clients. So in other words, now they can not just kind of draw diagrams and say that looks fine. They can actually envision what is going to happen, how it's going to happen, retries, routing, publish, subscribe, and so on and so forth. And then you say, okay, well, now we can actually take that and extract these pieces, and each one of these boxes effectively becomes a single SprinkleStream app, and the pipes become remote messaging systems. So, highly recommend. All right, so SprinkleStream. So we kind of had a quick preview. So what is it? It's a framework to build highly scalable, event-driven streaming microservices, right? Provides boot-driven integration with message brokers using destination binders. So as I already mentioned, I would even rephrase that SprinkleStream is really a binding framework, because all the internals that in terms of passing messages and everything else, that's kind of done by utilizing Spring integration and other Spring messaging libraries, right? So it leverages native features of brokers while also providing workarounds for not supported features. This is actually very important. So for example, how many of you use Kafka? Okay, so Kafka, great. Kafka concept, so you're familiar with concept of consumer groups and partitioning, right? So Rabbit doesn't provide that out of the box. But because Rabbit provides internal routing features, we were able to build consumer groups and partitioning inside of Rabbit. In other words, it's basically inside of a binder. So we kind of emulated what Kafka does, right? So in other words, that's actually pretty cool, because even though that's really what I was trying to say, that even though the underlying messaging system does not provide that out of the box, you can actually, with a SprinkleStream Rabbit binder, you actually have that feature. So that's a feature of the binder that build it internally based on some of the functionality that was available in underlying messaging framework, in this case, RabbitMQ. So, and it honors application configurations by the underlying frameworks. I'm going to quickly switch back to, I'm not going to run any code, but for example, I use Stream Listener. I just want to emphasize what that last message means. In Spring integration, for those of you who know, there's another annotation called add service activator or add transformer. I could easily substitute this to add service activator, and everything will work the same way. Okay, so I'm going to do like add service activator and then define input channel and output channel, and everything would be the same, right? So in other words, we honor we honor whatever frameworks that's internally. We will honor those configurations and we'll bootstrap it. So in other words, if you're migrating Spring integration application into SprinkleStream and you're not comfortable using two annotations, you just want to use one service activator because you're familiar with it, then go ahead and use it. Okay, a few more slides. So transparent content time negotiations, we already saw that. ability to connect microservices to external system via binders. We already kind of touched on that. Flexible programming model. This is what we're going to be talking right now for the rest of the presentation. So built all in Spring idioms and so on. All right. I kind of want to rush through it. So it's a boot app, as everything else in Spring right now, right? You can use flexible configuration. You can use, I'm still mentioning XML because you know what? I'm still a fan of XML. I don't care what anybody says. Things were, but again, you can, what I'm trying to say is that you can, we provided annotation configuration, we provide boot configuration, but we never really deprecated or moved away from XML. So whatever you want to do, whatever flows your boat. So binders, we have Kafka, Rabbit, and then a lot of community-driven binders like Google, AWS, Azure, Solus. There's a few other binders that I was asked to review from Microsoft. So there's more binders coming on the pipeline, and we are actually planning right now in the early stages of our socket binder, which will give us the full reactive back pressure support, and so on. So, and a seamless integration, because the boot application is a seamless integration with the rest of the Spring stack, like metrics, sleuth, config, circuit breaker, whatever it is you wanted to use. So this is really kind of the last slide. This is really what SprinkleStream is. So you have, at the very core is the destination binder. So destination binder is the wrapper into which you're going to slide your application, right? So you can swap the binders. That's at least the idea. Kind of write once and then invoke it from anywhere type of thing, right? So, and then binders allow you to connect to a variety of different messaging systems. So again, in this slide, I'm kind of showing you that you don't really have to use single messaging system. You can receive a message from Rabbit and send it to Kafka or vice versa, or use a variety of different messaging systems. So that's really what SprinkleStream is. So let's go back to programming model and, well, I'm done with slides. So let's get back into the code and start talking about what's new and exciting. So if you look at this application, right, doesn't it seem to be a bit verbose? I mean, if you think about it, I already told you that I brought the binder into my POM as a dependency, and that enabled send and receive messages, right? So why do I really need this? Why do I also need this? Because effectively what I'm doing here, if you look at what is the, so this is enable binding. The processor is basically a binding interface based on which we're going to create a message channels, right? We're going to create a proxy over them. So there are message channels. So now all of a sudden you, as a developer, have to know about message channels. So now as a developer, all of a sudden you're exposed to the fact that the message arriving from RabbitMQ or Kafka is going to be sent to the internal message channel, and at that point of time, Spring integration is going to take over and invoke your message handler on your behalf, right? Why do you really need to know that? I mean, think about the underlying story. You want to write a function, you want to address the functional requirement, and you want to be able to, the framework take care of the rest. You don't want to know about that internally. It deals with channels, because in some binders, there's no channels. Like for example, KStream binder binds you directly to the message handler, right? So it's like, to me, when I took over the framework, it seemed to be like it's a little bit too verbose, a little too much information that I, as a developer, would prefer not to know. So I decided I'm going to remove all that. Okay? So we're going to go back to the blank sheet of paper, and we're going to do this. All right, what do you see now? That's the only notation that is relevant in Spring, right? So what you see now is nothing more than a Spring Boot application with a bean of type function. Okay? Now let's start it. Let's save it first. And everything's working, right? So what do you think? Is this better than the previous one? I think it is, right? So what I'm kind of opening up to is that Spring Function. So a younger project compared to SprinkleStream. It's only about 2 years old, maybe a year and a half. But what Function does is it basically brings Java functions into the Spring ecosystem. So as I'm going to go along, you'll see some of the kind of features of it. But the point is that you can now represent your functional requirements using function, consumer, or supplier, or implement them. And we, for example, within SprinkleStream, will effectively know what to do. Now think about the amount of knowledge that I was able to extract from it to avoid extra configuration. You provided me with a single bean of type function. Okay, fair enough, which means I have no conflict. I know that within the concept of context of a SprinkleStream, if I see a function, that must be a message handler, kind of a duck typing, right? If it looks like a duck, walks like a duck, must be a duck, right? So the same thing here. And because it's a function, I know it has input and output, because I could also do the consumer, which would be only input. So this way, I don't have to declare whether it's a processor, source, or sink. I can extract it just from the signature of your function. Okay? And basically, I don't have to provide any configuration. Okay? So now the same thing will work if I do person. Right? I would have to do get name. Right? So now I'm going to right? So the same type conversion, everything works the same way. Now we're getting to the cool stuff. What if I, since we're writing functions, how many of you are reactive people? A few. Okay, so you probably prefer to write function in a different way. You probably prefer to write it and then we will have to change this. Right? So now you can actually build internal reactive pipelines within the function itself. So again, I'm going to start it. And everything works. All right, moving along. So now I'm going to do another function. And it's also a bean. Okay? Now I have two functions, so now I have a conflict, right? So I need to be able to somehow resolve this conflict. But, so what do? Now I can specify, in other words, now I'm kind of following, so when I left Spring, boot didn't exist. When I came back, boot exists. And I kind of decided to fully embrace it, at least in my thought process. So I'm like, I really want to only force you to configure something if you absolutely need to. In this case, you have a tie. You have two functions. Which one do you want to bind to the messaging system? So you're going to have to tell me. So right now, I'm going to require you to provide a property. So Spring. Now, why property? Why not annotation? Because property, while I'm providing it through code, you can provide it with the properties files, right? Application.yaml or whatever, right? Or just from command line. So you can actually make it more dynamic. Spring cloud stream dot function dot definition equals uppercase. Spring cloud stream function definition uppercase. Okay, so right now I said, okay, well, I have two functions. There are going to be two beans loaded into function catalog. However, when I send the message, well, I didn't put a system.out@print line, so let's make sure I'm not lying. Get. Here's my hello. Okay. So, any questions so far? There's more. Okay. So now, here's another, like Spring Cloud function. Okay, so you made a function out of a bean. Well, I did more. What I can do now is, one of the benefits of Spring Cloud function, well, before I even go there, first of all, what I love about functional programming, or actually the three interfaces, function, consumer, and supplier, is because I always do this. I always ask this question, which is kind of rhetorical, but makes you think. Is there a requirement, a business requirement that you have dealt with, dealing with, or will be dealing with that cannot be mapped to either supplier, function, or consumer? Think about it. It's like if we had these three interfaces back in the early days of Java, a lot of the APIs now would have been much simpler. Okay? So, but one of the features of Java functions is function composition, right? So we always talk about how do we, how do we write our code in terms of quality of code? How many requirements is too little or too big, and so on and so forth. Let's say we finally come to a conclusion. Well, now you decided that I'm going to implement those requirements using functions. But once I implemented them, those requirements are actually part of a bigger requirement, right? I remember like Rod Johnson was always saying that there is no such a thing as a complex problem. Every complex problem is just nothing more than an array of simple problems, right? So the same thing here. I mean, you want to be able to look at your requirement, break it apart by on very little pieces that are manageable, that are understandable, implement it as such, test it as such, but then you want to reassemble it back into one cohesive big requirement, right? So what I want to do here, emulate this by simply saying I want to be able to uppercase and then echo, right? So what I just did, I've composed. That's why the property called not name, but called definition, because I can point to a name of a single function, or I can point to a definition, which is a composition instruction to compose multiple functions into a message handler. So in this case, we probably should be able to see the value to be uppercase, because we first going to invoke uppercase, then we're going to invoke echo, right? Yes. Yeah. Because it's the same as, so the reason why I brought up functional composition is because in the pure Java functions, you can say function A and then function B and then function C. That's exactly what we're doing here. So yes, it is by, so this is good. The question was, for those of you who didn't hear, will this pipe implies delegating back to Rabbit and coming back, or is it internal just composition? That's internal composition, that's the answer. So we basically composed a single function out of two functions. and we got hello. Okay? 10 more minutes. Just enough time for the coolest feature. So now, these are the features that are currently available, and there's more. Like I said, 15 minutes is not enough. I'm just kind of pick and choose what I want to talk about. But one of the new features that is already in the release, and there is more improvements that I actually done yesterday, routing. So a lot of times, like when it comes to Spring Function, well, forget about function side specifically. I'm going to talk about SprinkleStream here. So in this case, I need to provide instructions to go here or there. But let's pretend you have a use case where, based on the message, you want it to go to this handler or that handler, right? So you want to be able to do some kind of a routing. So what you can do is use the routing feature of functions, which is what it is basically in Function, we've defined a single function called a router, right? It's a well-known name. It's documented and everything. So all you need to do is, for example, there's a couple of ways of enabling routers. So what I'm going to do is to say Spring Cloud I just wanted to. So what I'm going to do here, I said Sprinkler function routing enabled, right? So this function is not going to be enabled by default. It's going to be enabled only if you provide an instruction, because we don't want to pollute your environment, or even in case if you decide to create your own function name router or something like that. So in this case, routing function will require an additional meta information, because it will receive the message on your behalf, and it says, okay, well, who do I call? So in this case, because remember, I had to constantly start and stop a server every time I wanted to change something, right? In this case, I'm going to start it. I have two functions in my catalog right now. And now I'm going to go here, and now I need to provide additional information. Now, again, one of the features of the binder is whatever the information, like HTTP headers or message headers from RabbitMQ or message headers from Kafka topic, they're going to be translated to message headers within the internal message representation. So that's, again, something we do for you. So basically what I can do is I can say function dot name. I got it. Like, why is it? Function name is going to be echo, and content type is going to be text plain, right? Function name, yeah. Okay. We got the hello, right? And if I wanted to do uppercase, uppercase, right? Barcelona. Obviously, we're not going to see it in the console, but we can go, because of how I implemented it, but I can go to output queue, and here's the Barcelona, right? So all of a sudden, I was able to, so now you can imagine, you can be sending messages, and somewhere in the upstream is going to inject a header called, say, invoke this function or whatever, and what we're working on, which most likely you're not going to have to do, because what we're working on is ability to provide an expression which will evaluate any header, and based on that, so in other words, you can have some native message coming in, and based on some value like accounts or whatever, you can route a specific function, using an expression. Okay. Now, again, going back to the whole Spring Boot mentality, where you don't want to configure unless you absolutely have to, right? So obviously, in this case, I have two functions. In other words, so in this case, I have two functions, and I enable routing. Another way of enable routing is basically go back to using Spring Cloud Stream dot function dot definition equals router, right? So you effectively enabled router by saying, okay, well, I'm going to use the router as a function. So there's two ways of enabling it. The reason why this is important is because what if you want to be able to route to something, and then the result of it has to be piped into something else, right? So that's kind of a cool thing to do. So again, so we're gonna route. We're gonna invoke, let's say, uppercase, and then we're gonna do the echo. So I guess what I hope you're observing is that you can build now very complex pipelines within SprinkleStream by simply addressing manageable requirements of a manageable size, and then compose them, route them, and so on and so forth. So we started. Now we're going to go back to Q, and I'm going to say the same thing. So I'm going to do function dot name equals uppercase. We're going to route to uppercase, and then content type to explain, and then it's going to echo hello Barcelona. Okay. One last demo is, what if you, like I was saying, that's you know, somewhere in the pipeline you want to be able to have a function that will actually, because you may not be able to know which function do you want to invoke, but there is a function upstream or somewhere within one of your functions. I'm sorry, Jesus Christ. One of your function will know based on some information internally which method to invoke. So I'm going to call it enricher function. So let me write it real quick. So and it's going to be message and what we're going to do is we're going to say okay, I'm going to say builder that with payload value that set header oh. Okay. So basically we have a function called enrich. So what I'm going to do is thank you. So I'm going to do the enrich. So we're going to call the function, basically create the pipeline where we're going to so when I send the message, it created this one big function where the first function is going to be invoked as enrich function. Then obviously at that point of time, it's going to inject the header, knowing which route, it's going to send it to the router function, which already going to have the header, and then it's going to go into the echo. And we got it. Okay. So guys, it's 9:50. Thank you very much. I'll be out here for any questions. What I would also recommend, like I said, Jakub is presenting next. He's got really cool demos and really cool content. So thank you very much for attending.